Okay, Walter, here we go again. Sunday morning, and I'm going to try something else here. I realized yesterday, that I didn't have the mill set up very well. I just quickly, but I don't think it made much difference. But this morning, this was just an old piece of cast iron, the same one I was using yesterday, but it was just bandsawed out and didn't really fit in the vise good and blah blah blah, So anyway, this morning I squared it up with the mill and set it in a bigger vise. So the vise has got the whole thing now, and it's good and tight in there. And actually, I came out here in the shop to set up the 2-insert cutter that's 5/8, but I wasn't able to do that because it won't fit in a 5/8 collet. It's 16 millimeters, and even though when I bought it, I knew it was 16 millimeters, but it did say 5/8, so I didn't actually go check, but I guess 16 millimeters is larger than 5/8, so it will not go into the collet. So I have an adapter for this mill that lets me. I have a 10 millimeter collet for the ER16 system. So as it turned out, the adapter internally, even though I put the 10 millimeter collet in there, internally it was only 3/8. Well, let me put it this way: it had a 3/8 ridge down in the center of it. So I took a hand reamer, and I don't know if that's in focus, I have no idea, but anyway, I took a hand reamer to it, and there was a ridge down in the center. I reamed it out to probably somewhere in the neighborhood of 10 millimeters so I could actually put this up in there. So, it's the best I can do under the circumstances, but I'm sure this adapter isn't the greatest situation, but it does adapt it from an ER16 up to a R8 spindle. So anyway, that's that, and it's clamped in the vise well. Everything's tight, and I'm going to just run the video quickly. But what I did was, and what I realized after making one cut this morning, was that probably I should increase the speed. So, I don't know, but I suspect that slow speed doesn't really work well with this cutter. Anyway, I checked my speeds and feeds calculator, and I put in a 3/8 width of cut of 3/8 and a depth of cut of 30 thousandths, and I just told it was mild steel. It is cast iron. I could change the feet per minute on that, but anyway, it was telling me that I should be running the mill at 3,000 RPM with a feed of a 4 to 5, slow feed, high RPM. Anyway, I can run this mill up to 2,500, but right now I've got it set at 2,000, and I don't know what's going to happen exactly, but I'm going to put some depth of cut in here. And I think right now it's at 0. We'll see. Let's fire it up here. Okay, so there the spindle is going about 2,000 RPM, I think. I can put you probably can't see this, but anyway, I can put this on there, and then I can hit memory. I don't know if it'll show. But I don't know if it showed or not. I have no idea. I can't see it. But it's around 2,000, 1,900 RPM right there. So let me make sure we're at level. We're not taking anything off. Let me just go in here a little bit and see. Yeah, so it's not taking anything off there. So let's go back out again. Okay, I'm just going to set it at, I don't know how low I can go here. Probably I'm gonna move this down. Let's set this. So let's move it down to 20 thousandths cut. Right there. Let's put this back on 0. That way. So there's 20 thousandths cut. And so let's move the table in this direction here. Let's see what we got. And it's cutting out about, well, I don't know what it's cutting out, but it's less than 3/8. I hope nothing bad happens here. I'm never running this high of speed. Like I say, according to speeds and feeds on the calculator, it says 3,200. I got the feed going pretty slow. I could probably change the RPM on the calculator. Let me see if I can do that. So if we go to RPM and I change it to 2,000, then check the, now it's telling me if I'm running at 2,000, I should only be feeding about 3 inches per minute. So that might be about right. It might be about where I'm at. I'm not sure. I think the power feed runs it up to 20, and it's at about 1/4, which would be 5, but this block is probably about 3 inches. I'm just guessing, a little bit over. So it's taking off 20,000. The chips are like dust. Doesn't seem to, sounds pretty quiet coming out of the cut. Doesn't even seem to phase it. Usually coming out of the cut will make noise. Let me speed it up here, come out of the cut. Alright. Well, I don't know here. Let's try 30,000. Let's get this back to 0 here again. 10, 20, 30. There's 30,000. Well, let's see. I don't know how slow I can run this thing. Let's see how slow I can run it. It doesn't run as slow as, I mean, you know, there comes a point where you have to get started here. Okay, there we're taking 30,000 off. And I'm running about the same speed. I don't like putting my finger in there, but I just wanted to feel if that was warm at all. I don't think you're going to like going at this speed. I can try cranking it up a little bit. But I gotta try to obey since I don't know anything, I'm trying to obey the speeds and feeds calculator, but then I might be able to take a bigger depth of cut. Let me put the depth of cut in here, see what it says. So let's change the depth of cut to 30,000. Oh, that's where it is. Oh, I had it at 30,000. Let me go to IPM. It says IPM of 3. So, you know, I don't know how accurate that thing is, but my viewer's in my shadow, so I can't see the damn thing. Let's see if I can speed it up, because that seems awful slow. Seems like it's been a minute to get 1 inch. I feel vibration there, so fairly smooth. I mean, this thing's got vibration, so there's no doubt about that. I think we're pushing it right there. And I don't like the chips. They're just dust. To be honest, I'm not impressed with this. I don't know what the advantage is unless you're trying to cut something soft, like aluminum or something softer, making big chips or something that that have to have room to clear out. Otherwise, I don't see the point. I'd much rather be running a standard 4-flute windmill. I wish I could test out the 5/8 or the 16mm true flute this morning while this is set up. I thought I could. I thought I was just going to stick it up to the 5/8 column and we'd be off and running, but it's not going to happen. So, I guess if I want to use it, I'm going to have to get a collet for it. They're not expensive. R8 collets are cheap. But let me finish the cut. I don't want to forget, so let me move this back down. I usually run this about 1,000 RPM. And that's about right there. It's my best guess. So, okay, so I'm going to shut it off. Put my hand under here. I don't know if you can see this or not. Probably. Let's see if I can turn the viewer. There's my hand. Well, I mean, probably I can't do it. I need to get under the light here. I got a light right here. Right there between my two fingers and the palm of my hand. There's a little bit of, but it's just like dust. I mean, it's, there, maybe there. Anyway, it's just dust coming off. Take my word for it. And it's dirty dust. Nasty. I don't like it. Anyway, that gives you an idea. A little bit better than yesterday. So it's just going to be a very short little video, but I wanted to actually set it up more solid, put it in a bigger vise, and I kind of thought last night that the RPM should be up. So when I came out here this morning, I have the calculator out here, so I checked to see theoretically what it should be. Although that isn't always true, but I guess it gives you an indication. So, okay, I'll sign off and post this video, and hopefully it'll be of some instructional value. And I'm not the one to be giving instructions, that's for sure. Okay, I'm signing off.